Outreach. Are you muted?
We should hang up on the.
Yeah, I was trying to. I'll just check we're muted first.
Okay.
You're not muted.
How do I get out? Which one?
Here.
This one, I think.
No, but if you want to hang on at the meeting.
Mm-hmm.
All right, great.
Okay, and then let's see if we can get.
You have to use the black one to switch inputs. I think it's deep.
And then let's see if we can get.
Use the black one to switch.
There
we go.
Elevator. I'm muted, yes. I'm going to get my little speaker.
Here. Sorry about the random rant at the conference room upstairs. Just
Sure we are muted.
Can you guys hear us?
Hi.
Can you hear me?
Yeah.
Okay. All right. Well, I see we have a lot of people here, and I don't know if the Hangouts on Air max out at 10, but if they do, Katie has posted a link to data management HIP chat room. Okay, so Matias will talk to us a little bit about EasyAccess and what he's been working on for DES. So Matias, if you can start, and I'm not sure if everybody here knows you yet, so if you could briefly introduce yourself. What do you work on, both in LSST and outside of LSST, maybe for a couple of minutes, and then share the screen, and it's all yours.
All right. Thank you. So yeah, hi. I'm Matias Carrasco. I'm here at EasyAccess working half-time DES and half-time LSST. So for DES, I'm a research scientist here, and my background is in astronomy. I used to do photo-C work for myself and also for DES. So my role in DES is photo-C stuff, database stuff, and the things I'm going to show. Basically, I'm kind of the liaison between the data management and the rest of the collaboration. And for LSST, I just started last year 50% with LSST, and we're doing this super task framework with Gregory and some Square people to redefine the framework for running command line tasks in the pipeline. So what I want to talk about today is the way we are trying to provide better access and better tools and software for the scientific community, especially for the DS collaboration, to access the data that is being processed and handled here at NCSA. So the reason is well, I just want to be going to give a brief description and some demo of the tools that people at DS is using that is being developed here. So this is the very simple outline. I'm going to talk about EasyAccess, which is a command line interpreter or a client for accessing the Oracle database, where we have all the catalogs here. I'm going to talk a little bit about DS Labs, which is kind of an experimental tools that we're developing. And one of them is incorporating Jupyterhub and DES or EasyAccess in other words too. And I don't think I'm going to talk about the DES cutouts, but we also have a cutouts server for making thumbnails from the feeds file. So EasyAccess is a command line tool. It's written in Python and it's open source. Yeah, there's a link to the GitHub page there. It's it's meant to be only for DES in the sense that it's being developed thinking on DES collaboration. So it has special feature for our own database, but basically it's a wrapper to get access to the Oracle database. This is the one we use. So the motivation for writing EasyAccess are many. First of all, the DES database is all Oracle, which for some things is very optimal, but from other things it's not very optimal. But that's out of the discussion in this talk. And we used to have a command line interface to access the database, which is trivial access. And the reason we want to provide this is because not always people can install whatever comes with the Oracle client. It's not trivial to use, and that's why Don, a few years ago, wrote a little interface program, which is Java and Python, basically, to access the database. And the idea was to add some extra features to the Oracle client to make the access easier. But then that was trouble because it was slow and it was written in Python and it wasn't clear how to keep developing. So I took the software and then refactored it and added more features, and it's all in Python right now. And basically it's an enhanced SQL command line interpreter. And it's astronomically friendly, meaning that it has all the features that we scientists like auto-completion and find users or find tables. And since it's written in Python, it also has a Python public API that you can access from a Python notebook or a Jupyter notebook. And also we are working on a web interface for it, which is basically calling the same software. And even though there's many other clients out there to access any database, we needed one standard and one for beginners to make uniform across the collaboration, so we can support that and we can help to get it started. So that's kind of the basic motivation for this. So some of the cool features for this interpreter is, well, you have a story of the commands. It has a very, very smart tab auto-completion of the commands itself, on the tables, on the columns, on the users, and on the path, and some other too. So I'll show that in a second. But basically, as you write your query, this auto-completion is following you, and it's not a make suggestion, but you can type tab and see what's available. It has a lot of configuration, so you can make it very flexible. It's completely open source, and the cool feature that people like the most is that you can write tables in just one line. You can write tables in either CSV, comment separated value, space separated value, fits, and HTF5. And also you can load queries from a file directly in the interpreter, and you can also load tables directly into your own space database in one step. Given the right format, you can load tables and then share with others. And that's also a very useful feature among us, because sometimes you create a table, you share it, and it's very easy to do that. You can use it as a Python module too. And all the tables are handled and displayed using pandas data frame, which is also make things very convenient. And we have a beta feature, which is now you can run Python functions inside the query. I'll go through that in a minute. And there's other nice features too. So not only you want to make it easier to use the database, also you want to make it easy to get installation. So you can either clone it from the GitHub repo. It's on PIP, or you can use EasyInstall to install it. We have our own UPS distribution package here, so you can use that as well. Or you can use a pre-install version in a Docker image, which is also distributed if you want. for DES collaborators. And the good thing about Docker image is you don't have to worry about installing the Oracle client, which is kind of a painful part. With the Docker image, EasyAccess comes pre-installed, and you can run it from outside the container. You can mount any volume on it, and you wouldn't even notice where it's running. So that's also been very, very convenient.
So Matias, if I can just ask a question. If you're installing it using pip, then you must have an Oracle client already installed, or does it pull in an Oracle client as well?
No, you have to install the Oracle client. That's the main major pain in the neck, because it's not that you cannot do it, and it's free if you install the Oracle client, but you need to register, and
yeah.
So it's not straightforward. But once you have the Oracle client, then it's straightforward to install it.
Thanks.
So let me talk a little bit about some statistics we've been collecting. So the first version of EasyAccess was launched roughly a year ago. So since then, we have doubled the number of users. Because one of the features inside EasyAccess is when you load it for the first time, it creates a series of metadata tables. So that's why we can also follow how many people is actually using these tools. And so I have a little plot here. On the right is showing the number of EasyAccess users, and on the right is the total number of users in our database, which basically the number of people in the database. Some of them are gone, and we haven't cleaned up all the users, but on the red line you see the number of EasyAccess users, and now we are roughly 160 users. Not all of them are active users, but at least they install it and then they run it at least once, so we know that. And we probably have a few dozens of active users. So we have more than 150 users with different activity levels. So some of them are actually using on a daily basis. Some other just to get data for a particular thing. We get all the feedback via GitHub issues. We have a question like a Stack Overflow like question system in Confluence, in our own Confluence. And we have an email list and, of course, personal inquiries. So we have some statistics on the quotas. Everybody has a personal space, and given that now it's easy to upload tables from a file and share it, this space is also been increasing with time. Now we have more than 4 terabytes in personal space among tables and index tables from the users. So this is also a good indication that it's being used. So before the demo, I just wanted to mention a few things about what we want to include in future. One thought is to make it a general tool for any SQL client, not only Oracle. So the idea is to use SQL Alchemy to make it more transparent and make it more general. Another thing is the inquiry Python function that I'm working on right now. Also, we want to include some, to allow the user to send batch jobs, so you can submit a query and then you can disconnect and then you get an email when it's done. The same with checkpoint. We don't have a checkpoint, so if your connection is broken in the middle of a long query, then you need to start again. We are working on a web server and a better Jupyter integration and some others. So there's a paper, hopefully soon, on this, hopefully this year. And so I have a link to a tutorial there for a more detailed tutorial that I use to show the collaborators, but it's open, so you can see it. So let me give you a brief demo. So there is. So this is a pre-installed EasyAccess in one computer. It's not Nebula. We have different cloud systems here, but all of them use OpenStack. But you can think about having this computer on Nebula. So this is the welcome page. This is the EasyAccess, and you can type help or see what the commands are available. And one of the features that I mentioned before is you have an auto-completion feature for the commands and also for tables. So I just type describe table, which is for describing a table, and you can say another example. We have A1, the first year release tables, and you type tab, and you can see all the possible tables that start with that string, and then you can
Matias,
sorry.
Matias, is it possible to increase the font size a little bit? Jim is saying that it's difficult to see on his end. Great, thanks.
So as I said before, it has a pandas running on the background, so it's displaying data in pandas format. So it's nice output format. So you can describe table. You can also when you type select and you type tab, you can see all the possible columns in the database. But when you find one column, and then you say it's from, it's gonna give you all the tables you have available. So it's kind of following you along. So it makes you easy. And then when you type where, it goes back to columns and so on. So
is that all the tables that have that column, or is it all the tables, period?
All the tables. Yeah.
Okay. Yeah. That would have been really fancy, but
yeah,
still good.
It is. So, but you can also have you can look for tables beforehand. So you want to print all the tables with that pattern. Of course, there's no. But they give you all the tables with that. So yeah, that's right. Ideally, we should only show the tables with that columns inside that, but that would be require a lot of metadata cache. But I think it's possible too. So you can also find users. Say you want to look for Don, and it give you the user. So as I said before, one of the nice features that people actually is using and they like is that you can output all the results to the screen, or you can just redirect that to a file. And I'm going to call the LSST demo. So it's gonna take so here that query into that file. That's a small table, so it should be fine. And it wrote 13,000 rows in 0.8 seconds. But also you can output that to fit file, or even HDF5 files. So you can access your path with the exclamation sign, right? And then you can see these files were created there. So that's very convenient. And also the other way around, you can load tables from a file, in this case only from fits and CSV files, into the database, and it takes the name from the file name. So you can say, it's a very simple process. You can say load table. You have auto-completion also for the path, so you can just say load table LSST demo that fits. And it reads the file, and it creates a table and insert all the data in that table. So now we have this LSST demo table in my own schema.
Does the file have to be in any special format, or what are the limitations?
So for CSV it's very simple, but for FITS file we have some predefined formats. So we have some data types we can use. It has to be a binary table. But other than that, that's basically all. It doesn't support very complex data types because it's hard to convert them to Oracle data types. But if you create a table from this client to a FITS file, then you can easily read it back. Because Oracle, I don't know if you're familiar with Oracle, but Oracle uses number data types for all floating numbers, and sometimes it's hard to distinguish between float binary or double binary or just integers or so we have some rules, but in general it's very straightforward. And so now if I refresh the metadata, when it's done, it takes a little bit. Now the new table is going to be in my metadata schema, so I can use it for auto-completion. And if I want to get the table with others, just write a command and run select to data. So now I can say describe LSST demo, and I have the table there. So that's why now people is using it, because you download some table, you do some quad value catalogs, and then you just put them back to the database. We're talking small tables. If you need to do a large table, we have also a separate workflow for that, because sometimes it takes just longer. So so another feature that I was working on, I mentioned before, is that, let me type. So I'm going to just select array and dig from a subsample of one of the table, and just get the first 10 elements. And as I said before, you can write comments inside the query. That's a standard, right? So I can say comment, and of course it's going to ignore that, and it's going to give me the same output. But if you give the comments with a special indicator that you are parsing a Python function that I previously created, I'll explain in a minute what it is. So I have a function, a Python function, using healpix or healpy, that converts from array and dig to healpix index using NSI 1024. So the reason we have this here is because I tried to investigate having healpix functions inside Oracle, but PL/SQL is not that trivial to write. So I've written some functions, but it's not easy. But with this function is written in Python, then you can call that, and it's going to be applied on the fly over the columns, and then you're going to get the result. So you can say select, give these decorators or pragmas. You call the function, which is called env to healpix, and I can give it a name as index, and then I'm going to retrieve anyways array and dig, just because. When you do that, you see that the first column is the index column, which is the result of the function that you applied, and then the rest of the column. So this is still developing. There's a lot of caveats to this, but this has a lot of potential, because you can always get the data and apply the functions afterwards. But the good thing about doing it on the fly is that Oracle makes different, several trips to the database so it doesn't retrieve all the data at once. And when you retrieve a chunk of data, you apply the function. So you can apply this function to 100 million rows. It's gonna take a little bit more, but it's not gonna kill your memory because you're applying the function on chunk of data. So, and writing this function is just as writing any other Python function. You have just one extra EasyAccess decorator to indicate that it's for this feature. So this is in development, but I think this is going to be.
So this is applying it to result, right? You can't then say group by index or something like that.
No. It's only applying on columns. Yes.
Yeah. Okay. I got it.
Yeah. So and also one of the features is that when you get tables that are too big, you can specify in the configuration parameters how big you wanna split it up if you want to split it up. So the default is 1 GB, but you can have files of 10 GB or have it all, or have 500 megabytes if you want to have it. So it's gonna get the data, and when you reach that limit, it's gonna dump the data to a file, and then it's gonna keep writing, and it's gonna have a continuous integers for the file names. So yeah, so as I said before, there's a lot of configuration. So I'm just going to mention a few. You can define, for example, what is the default database you're connecting to, what editor you can use. I'll go to the editor in a minute. Some other parameters, for displaying the data, and this in particular, this is what I mentioned before. What is the maximum size for each file when you output the data? Also, you can, since you can access the command, the system from inside, you can open a file. Which I already have an example file here. So this is just an SQL command in a file with comments and all that, and then you can edit here. You save it and you say quote SQL demo, and then it's going to print out the query for first, and then I can run it. So it also reads from file, and you can edit it as well. So I think that's kind of a brief introduction. There's a lot of commands that you can see here, but that's basically the most used one for us.
So if you had an Oracle database to install this, what do you need to do? Do you need to create some support tables, or how difficult is it?
It's not really that difficult. There's two tables that are special tables. One is for the users, but that's very simple, and the metadata. But the metadata is a standard for Oracle, so I don't think it's having this for a different SQL client, that might be a little bit harder. But for any other Oracle, it should work. Not out of the box, because this is of course for DS, but with very minor modification, I think it should work.
Mm-hmm.
So, is there any questions regarding this?
So I have another one. How difficult do you think would be to port this to SQL Alchemy or make it cross-platform in terms of databases?
I don't know. This is it's on my plate. I want to use SQL Alchemy because that's kind of the standard to generalize to any other client. But I don't know how difficult that would be because MySQL, these are different idioms, so that's also tricky. And also data types, it might be an issue here. Not only the syntax, but the data types might not be the same across different clients. So, but I guess I guess it's doable. So one of the things I wanted to do in the future is actually that, and we have just kind of on the side of the discussion, but Oracle is great when you have a lot of tables, but if you just want to have like a huge table with a catalog, we're looking for other options, and one is an in-memory database, MemSQL. So I'm planning to write EasyAccess to be compatible with that. So when we actually give it to the users, the user shouldn't know whether you're connecting to Oracle or to MemSQL in that sense. So, but yeah, I don't know exactly how that's going to be done. So moving on. Oh, here. So among the things that I've been doing, not only working on EasyAccess, but also try to provide better access to our data. We have this little TS Lab group where when I say we, it's basically me and some undergrads sometimes, is trying to develop different software tools to be integrated and compatible with each other. I'm going to just mention a few. So we have an EasyAccess web version, which is basically just a web interface, pretty much like Cascades, kind of. But it's also running EasyAccess on the background, so you can write your query. You have auto-completion here as well for columns and for tables, and also for queries. So let me go back. I'll go to Jupyterhub in a minute. So we also have, this is going to be pretty very slow through, but this is a WebGL display of the TS footprint. So you can, this is a little bit slow to see, but you can zoom in.
How's that generated? How's that generated? Is it from live data? Is it querying your database, or is it pre-generated in some way?
So we do have the geometry for all the tiles. So just displaying those. It's displaying the geometry that we have. So it's a pre-generated data. It's not querying the database live.
Okay.
So different colors are different years. So the pink is the SVA, orange is the Y1, and the blue is the Y2 data. So the idea here is that you can click on one of the tiles, and eventually you can actually access the tile with some other interface, but we haven't gotten there. But so there's that. We have this cutout server. This is sitting also in one of virtual machine that is connected to our GPFS file system. So it's actually getting the files, and you can make the cutout from there. Just submit a job with different positions, and you have all the cutouts, and of course the feeds files for different bands too. So, and this is also being used quite a lot. This cutout server. It's a very simple one, and some other tools. So let me go back. So I mentioned before, and this is going also to the other part of the talk, is Jupyterhub and EasyAccess. So as I say, EasyAccess is written in Python, so it has a Python public API, so you can run it in a Python interpreter. You can convert directly from the query to a pandas data frame, and you can work on the pandas data frame on the same IPython notebook or Jupyter notebook. So the idea of having a Jupyterhub is that you can have a multiple user Jupyter notebook sessions where you can access with your database credentials. Right now it's running on OpenStack, not Nebula, but it's the same OpenStack system, and it's very easy to set up. It's running from a Docker container. Right now we have only 10 to 15 test users. It's not widely advertised because I don't know we can handle that many users. but for testing purposes, it's great. So it comes with all the tools pre-installed, not only the Python tools, but also EasyAccess, Matplotlib, Seaborn, Pandas, and all that. So in the future, we are planning to integrate it with DS9. So there's a JavaScript DS9 version that we are trying to get it work inside the Jupyter notebook, so you can then display images and access the catalogs in one notebook. So that's part of the future. Also to have the GPS file system mounted, because right now this is running alone. So you can connect to database, but you cannot connect to the file system. So you need to transfer the image, and then that's very slow. But if you have the GPS files mounted, then you can access the image, display them with GS9, and then display regions that you can query from the database. So this is also work in progress. I do have a little demo, which is basically the demo that we use for our initial users. Let me click here. Oh, there. So I just did a little modification to make it pretty, and then I use the Oracle authentication, so it's checking against the database. So it's not LDAP, but it's checking the credentials from the database.
How difficult was that to do? Are there hooks already in Jupyter for authentication, or?
No, there's not. I have to write my own patch for that. But it's not so hard. It's because it's all in Python. So I use Python to actually check against database. But yeah, so.
Okay.
So I think they do have authentication for Google, for example, and also for GitHub. But we have to check against the database because security.
Sure.
So this is a welcome notebook that everyone connects for the first time. They have access to these. I'm gonna make them all run. I'm gonna just explain them in a minute. So basically, here you have a home directory where you have the IPython notebook. You can create each user can create their own IPython notebook. You don't have to worry about any installation. Just go to the web page, enter your credentials, and you're set. Here you see the EasyAccess Python API, and then some other standard packages. Here you connect to the database. So this is when you actually call and make you checks against the database. You don't have to enter your password because it's already stored. Here's an example query similar to what I did before. It's just getting some data from a stock sample table. And this is the line. In one line, you can get that query into a pandas data frame. You can change the display options just to make the table below. So here I'm just printing a summary of the table that I just got from the query. I can do some plots, and this is just once you have that in data frame, you're done. So you can make plots on the density, some contours. You can plot the distribution of one of the magnitudes. So the good thing is that you already got the data, and then you can just forget about it, or you can actually put the data back into the database if you process the same way you can upload tables. And also you have a public method to say query and save, so you can save, you can query and get the results and save to a table, to a file. Same way you do in the command line interpreter. So this is basically saving the query to a my table. You go to your home directory and it's there. So as I mentioned, one of the idea of having this integrated is that once we make it to work for DS9 to be displayed embedded on the Python notebook, and if we have the GPFS mounted here, you can actually access the images and you can access the catalogs, and you can interact all together. So you don't need to bring anything to your computer. Everything is done remotely, which is can be very, very, very powerful. So way back. Well, that's basically it. So we have we're developing these tools to make the data access easier, and it's not pun intended. We call it EasyAccess because Don, when he wrote the first old version, he called it trivial access, and even though now it's trivial than before, we have to change the name. But so the idea is to make the people, not only scientists, also grad students, undergrad students, to make it easier for them to access the data without worrying much about installations or other probably just to get to the science as soon as you can. It's all open source, and the idea is to have this all integrated to each other. So the footprint map that I show you should be all integrated with with the database and with Jupyterhub and all that. So we can take advantages of having everything in containers and having everything on the cloud. And this is a standard conclusion, but this is true that bringing the software where the data is sitting is way more efficient, and you can do much more cool stuff than the other way around. So yeah, I think that's all.
That's really good. Thanks, Matias. Clapping was difficult remotely.
Yeah. So, is there any questions?
KT, if you're trying to say something, we can't hear it.
No, sorry, I was just chatting with Alex here, bringing him up to speed on.
Oh, Alex. Oh, hello, Alex. So I have a quick question for Matias. So you mentioned JS9 and trying to integrate that with IPython notebooks. Have you actually gotten to attempting to do that, or do you have any experiences to share or report?
So no, well, so you can embed, you can have, sorry, you can run JS9 on a remote computer, and you can just have this magic HTML thingy, so you can call it, but it's not. But it's actually when you actually load data or load a file, it's actually looking in your local computer. It's not looking in your notebook computer. Notebook account. I don't know. Is that so? So it's not actually embedded. It's just it's like having an iframe for the JS9 running somewhere else, and you can actually display images. But the idea is to have and they do have an API. So the idea is to use the API to send images and to send say regions to the JS9 display, but taken from your notebook home folder, not from your local computer. I don't know if that's clear, but so that's the tricky part, and I haven't had enough time to keep exploring, but I think it's doable, and once you do that, you can load images directly. You create the image or you create the catalogs and you load it directly in JS9, so it never goes through your computer.
Yeah, I think that Robert Lupton has done some work that tries to do exactly that, and then our IPAC team is also looking at doing the same thing with Firefly. I don't know who's online if you want to say something about that.
Yeah, we are working on, actually we have demonstrated some capabilities to have Firefly image display in the IPython notebook back in August. We put that effort on hold temporarily to concentrate on moving all the client-side code into JavaScript. After that is done, we will be able to expose a lot more API, JavaScript API, make it available for developers to use finer controlled capabilities in Firefly.
But that's exactly the way Firefly works. It reads the data from the server where the data is, displays it to the client without having to move the data over.
So Matias, we should definitely talk to see your objectives and see if there's a gap or anything we can do to facilitate that.
That would be fantastic. As I said before, I'm only 50%, and I have very limited time. So whenever I have a little bit of time, I go and try something else, and then it stops working. So the last time I tried, I couldn't make it to work. I could make it to work to display GS9 on the IPython, but I couldn't make it to connect to the IPython, local file system. So yeah, that would be great, because that would be very, very, very powerful for us as well.
You may also want to talk to Robert, because he has some Python code that abstracts DS9 calls. So you could have a local DS9, and you could have a remote piece of Python to which you can send images and regions to plot, and then that module handles all the communication with DS9. And I wonder I don't know how difficult would it be to just use it as a drop-in thing for your DES work, but it may be good to chat.
So I do have. I've seen it before, but that means you have to have DS9 installed locally in your computer, which is fine.
Right. Yeah.
It's completely okay, but the thing we're thinking is to have everything on just one Jupyter notebook, so you can access from everywhere. But yeah, it's going in that direction. I think eventually we can make it out. It's not. I think we're not that far.
Cool. More questions? All right. Thanks, Matias, again. This is I think a really neat and cool piece of functionality, and I think we all like auto-completion and like our access to be easier, if not trivial.
Yeah. So I'm gonna post. No, I don't have the slides, but I have a link to where the talk is sitting, so you can see it offline too.
Sounds good.
Thank you.
So are you going to post your slide on the RFD page?
Well, actually, I think the community announcement is probably the best place.
Okay, wherever you post, so inform us, we can take a better look at.
Yeah, I will.
Thank you.
Okay.
All right. Thanks, everyone.
Bye-bye.
Goodbye.
Bye.